Hey there, welcome back to the channel. So we are going to continue on our quest to make BFQ faster. Well, I have some things in mind. I did some changes, so as you can see, member initialization or something like that. I didn't quite remember what it's called, but yeah, that's that. Also, these can be just used with push, like duh. Also, we can use to remove so as to not create a copy, those kind of things. Yeah. And the error, I figured out, the error was because of this. Because here we were returning n minus 1, but end is actually the back of the queue, and we should instead be, and when we ask for front, it is actually the start. So we should return the start. So like, if this is the queue, this is the start, this is the end. When we push into the queue, this is what happens. And when we pop, this is what happens. So we should be returning start, which is this. And this is the top of the queue. Here we push, here we pop. So this is the actual start. So we should be returning start instead. So that's what I did, and it worked. Okay, so this is working. Also, I think we can remove lock guards, I guess, at right now. That would be super solid, but I'm not sure how it would be. And of course, it would compile. That is not the problem. What's the technology? So you clean and make a run. So here is the thing that I need to check. Like, is it really lock? Wait, 6,000 operations. Okay, that is faster. That is sus. But okay. So BFQ, I don't quite trust this though. So I am just going to let's add it over. So split C out, Q dot start, Q dot end, and what is the final capacity? So Q dot capacity. Two 73 nanoseconds. Why is it? Is it because we are recessing or something? I don't think we should be recessing. I think we should take the initial capacity and just stay true to it. Yeah, this is what we have initialized, and push doesn't do whole lot of stuff. So, okay. So int next will be where our next point is supposed to be, and it is present at, let's say, end plus one mod capacity. I think this should work, and then we should just sorry we should just next and do this, remove this, right? This makes sense, right? So int next is equal to end plus one, end plus one. Okay, so next is equal to n plus one mod capacity. So mod capacity sounds correct, sounds about right. So let's try that again. If there's an error, we'll find out eventually. So no big deal. We have just yep, there was an error, and the reason. I am really not sure what the reason could have been. Um, sorry. So here we go. So in the benchmark. So when you're getting a runtime error, it's most simply because system cout dot run and then you can do this, and this will be that's good. So we'll get to see what the error is about. Yeah, okay. So this is 0 and this is 1. I think I should also print the capacity at that point, like how much. No, capacity stays the same. I'm so sorry. Capacity stays the same for the entire operation, so this is really matter. But am I audible? Yes, yeah. So we are throwing the runtime error, should see out q dot find. So q is coming out to be 0. So why is that? So what my basic idea is, so we got the inputs and right? So we have start and end. So start and end are the only atomics. Rest of the elements can be free, and that is because we can just you know we don't really need it. We don't need all of the elements to be atomics. We just need to control the start and the end, which is the head node and the tail node. So the start is actually the tail node, and end is actually the head node. So should I change the names? But okay, yeah, fine. And they're fixed. So this makes sense. It makes total sense. We shouldn't be. Yes. Yes. We should instead be doing this. What is equal to next. So end of store. Next. Let's keep it sequentially consistent for now and then check that if it works. Yeah, it doesn't. And that is because why would you work? This is 0 and 1. So, okay, I can at least check like how many elements there have already been, what do you see? There's this one. Right, so, school.cout I. This is going to be bad. I should rather add a space towards better or something. Space, and there will be a single space. Let's try that. There's going to be a lot of eyes on the screen. Okay, so we reach 768 this time. Let's go. So when I hit 768 and let's try screen 0, it's so let's say I'm new here. So I'll remove this. So I'm going to benchmark and I'll remove the I statements for printing. I understand. That is it. Yeah. Instead, I would add So for int I is equal to, sorry, for int j is equal to 0, to j less than 1000, and g plus plus, we'll just create, I should trade q, just let's see out qj spaces. So let's see what we see. So no match operator of the types of if you, yeah, okay. I forgot. We should instead be doing the q.pf, not, oh, okay, no. Or is it because you lean or something? Benchmark.cpqj. Then where did we make the change? No? Oh, okay, I'm dumb. So the elements are correctly, oh, look at this. So this is starting from start. So there's a zero at the start, but there shouldn't be. So benchmark.cpp goes like this. So it's depending elements from zero, but it's not starting from the very start. And why is that? Because it's taking int next. When we push, it goes int plus one. We should just do int and the mod capacity, and then take care of int afterwards. Next plus one. Yeah, this is the stuff. I get it. So this should work. Okay, it seems to work. 6,500 operations and 370 nanoseconds round time. So I guess it's working. But still, what I'm going to do is, I don't know, I think we have done all, we have done enough. So to make it faster somehow, what we can add is, so currently it's testing with integers, right? I don't think there is much to do over here. In the mod capacity, let's plus one. We can just plus plus, no, sorry, let's plus one. Maybe adding state of memory order release. So we have end with us, and we want to do, but there is no, okay, there is no acquire. We are not reading it in that. But this is where we are reading technically. So star, then star, by default, sequential persistence. So should goes state and value is equal to end dot load state memory order But this should be a single operation, right? So memory on the wire, same goes over your student memory on the wire. What the student memory order wire username is going to change this. So start plus plus. So this is the read and write operation. So start dot store, or we can write fetch add. Fetch add is supposed to be one, right? So how much we want to add? This is memory order release. So this is how it should work. Fetch. Let me just clarify. So fetch add from C++. I'm going to be the result of automatic declaration of value and argument. Good. So this is how it works. This is fine. This is fine. This is fine. This is fine. This is okay. Ratio capacity. This is fine. Yep. So most of the things are fine over here. Okay. So this should give us slightly better score, but we can never know. So this is 13,000, and initially we got 317 and 2 basics. Yep, it's getting good. So is it done already? Since we have reached 236 nanoseconds already, so we have already beaten. Um, oh, and that wasn't fun. We reached 36,000 operations per millisecond because it was quite easy. There was no. But I need to check like is it working correctly. So I'll remove the this one. Yeah, let's make this. Let's make this one again. This, this one. Get diff, get deft. So we do this, this, lockouts, if we cool, and we'll launch that space, which is not cool. Line 92. Okay, effective benchmark. Okay, I'm just going to restore. So we didn't make a change benchmark recipe, it stays the same. And you have a new module in front of you, which is PFP, faster than. Well, but that wasn't fun. I did not have fun writing this. Why is that? Hmm. Let's see one thing. Let's add, not add, but let's remove this. So here, I'll just do one thing. I'll just take this function. and give it to ChatGPT and get a function that is compatible with Mac. You need to get something similar just for Mac. There is simply set recent for Mac OS. Yep, preference is set. So this is the Mac OS equivalent. Okay. So by doing this should work. So I should give it is the context of how big thread is your implementation. Does your implementation mean? Sorry, combines an element does not preserve the semantics it relies on. The code is true. The benchmark is created to introduce it on CPU banks and consider on CPU5. Set is version key does not point to a specific CPU, does not ensure separation. Only groups typed by a floating tag, what your current usage becomes accuracy. Different goals and methods which is assigned to our transition websites of the code. Not all directly entirely. One is matter specifically for the question. Performance goals. Okay, yes, events, no crashes, no debut, it's not. A simple dash of what you have, show the first performance. Check my address and this is how to play with Mac OS on. Set telephone course. It's not possible, but okay. So the code should work, but it's not going to work as it would. So, still let's still try it. So, where do I make a change? So, see desktop lazily fast view. So, view. So we have this. I have to change some reports. Still leave the thread is like this. That's not okay. We'll just improve that. Okay. Uh, it's fine. So I just think if we do that, correct top it's yeah. Let's compile the top again. So RM yeah. It's RM the top. Let's go to the yes C2 guys. CD which was include top. Mhm. Yes, please, you got it. Yes, this. Wait, why did I move it into what? I need to move that into SS. Yes, this into SS. And inside SRC, benchmark zero. This is this. This basically stays the same. And then we go to SRC, G plus plus, I plus plus STD, C plus G plus plus still does the connect plus plus. So S3 is equal to 17 dash of S3 and benchmark, like benchmark. Yeah, I'll put it to the dot minus 270. That's still 40, 40, 40, 40. And I did not change this. Where is my change? Did I change it somewhere else? Was this? No, you don't need to go there. Hmm? No, can I change it over here? No, I didn't. Go. Space security.h. Wait, what's this? What is the real implementation? Yeah, cool. Okay, fine, that's no problem. Just the function. So we have this video, and then let's see what can. And big dog. And let's first check if big dog executes. 19,170. Select dog, do this, and then EFT. Yeah, okay, so I can run it right now. Okay, and choose some stuff. Since it was on CPU 17, I can change the save okay, 15,000, and the latency is quite high, I think. Hmm, it's struggling. Definitely it will struggle because it's the old implementation. I haven't used the new implementation. So the new implementation is this, which I'll copy once it's done. Once this is done, yep, hello. Thanks for watching this video. Okay, so if you are watching this video so far, don't don't watch me doing this stuff, make your own stuff. There is no point in watching me doing stuff. You're not going to learn anything. Oh my God, this is taking a lot of time. Okay, if it doesn't return in 10 seconds, I'm going to terminate it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I'm sorry. I did do that. And our BFT implementation is okay. So this is going to be one. And wait, if I'm missing here, this is 8, 8, that's what I thought. Excuse me, a little bit. 20,000 operations, 115, 15,000 operations, 203. It's still high. It's nowhere close to what we could have got. So there is a lot of room for improvement, and we can do it. And there is the improvement then. We will use perf for that. So let's go and understand perf. Okay, I think we should end the video right now. So I can conclude that uh, at what is it, 115? Let's take the 115 average. 115. Let me calculate. I can just do it. So by 3. So 115 minus 204 divided by 115 times 100. This times 100 minus 77%. So you're doing something great because you were earlier very bad. So if I show you the previous code, so github.com and showing what's BFQ. So BFQ, the one on our main branch is actually very slow. I think this is pretty slow. It's not doing anything, just copy it. BFQ, boom, 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 boom. This is going to be so bad. I'll tell you guys the improvement that we have over it. The main thing that we are going for is the latency. Like the throughput is good, the throughput is OG, but we still can't ignore the latency because that is what is important to us. So the latency is okay. This is going to be a lot, right? Recording, recording, recording. Audible, audible, audible. This is bad. This is really bad. What's it going to be? 300, 400, maybe more than that. I need to make it faster somehow. How long is it going to take? Like, it's my CPU screen happening right now. Yep, it is. Should we read what laptop has done differently? Oh, that's basically size. If it's less than one, then it's one. It's one slack element. Window frame. Goal. Goal. If constant XPR has updated at least this value, I don't understand what this is. It's the same thing, I think. Nothing this that will deallocate all of this space. It uses a custom allocator. Okay, cool. First allocator, allocator. So what is this? Okay, in place, enter this point, study the cert. Yep. Student will relax. So you're getting the right ID. Next right ID is plus one. If next ID is equal to capacity, next right ID is equal to 0. Okay, so you're just doing a simple, you're not using the mod. It's that the thing, which is better though. Okay, let's check which is better. So God mode, .org, is over. Oh, 3,000 nanoseconds. We are so far better than that. So okay, so let's try. So none is equal to none plus y mod x, where x is this. Okay, to this. I'm also not returning anything, so return. Okay, so what this operation does is that we take the pointer, we load it into ex, we add it, and then this division happening at RBP4, which is x. So IDIV, okay, so I'm not sure what this does, but basically these are file operations that we have over here. And instead, if we do if num is equal to x, num is equal to 0, and plus plus over here, and this. So now we have one, one, two, three, dot empty jump. I think they are adding yeah, mod is better, mod is far better. Yeah, shouldn't be doing this. Okay, boohoo. And why is it relaxed? Shouldn't be relaxed, right? Like, do you want to? Sorry, I'm sleepy today. To forward this item. Stored. Because you are storing it again. If I do it relax, I think it will be much better. So let's check out. So we're going to move to this is the previous code. The cool one. So we often get 204. Yeah, nearly 200. So let's try replacing all the mail orders with just student memory. Yeah, let's stick change all the wires, logs, and then there's use change to the next. This will give us some kind of error. There will be some undefined behavior, but I just need to check how fast. Oh my god, that's fast. That is fast. That is really fast. 146 nanoseconds in 190. Can you tell me that again? Yeah, just in case. Okay, 147 nanoseconds. That is fast. It's still that the desktop is doing something better than that. Maybe it's the in place, maybe something else. Uh, Not sure. These functions are the questions what is important. No, except is this like what is no except what does no except mean in C++? Is it telling like there will be no exceptions, so don't look don't keep looking at it, something like that. So performs a content check that returns true if an expression is declared to not have any exceptions. Okay. Okay, that is good behavior. That is actually a really good behavior. Okay. So it means we this cool try push, whatever cool. Yes. I want to look at okay, let's say okay. Really explode is the same thing. Starts this and then the destructor is called empty. Let's keep adding this, this, density, left state IDX is equal to 0, left state IDX, size, okay. Where's the in place? Did I forget that? Wow, where's in place? Yeah, okay, let's see. Yeah, done. I'm not sure what is happening here. So new T stays. So we tell it like where do we want it? Is it something like that? And then it's created. Not sure. But okay. Cool. This is a very simple implementation. Okay. No except can do so much better. So no except if I had no except is not push. Maybe this will make it a lot faster. Maybe I cannot promise that, right? Wait, what? Yeah, it's just been at least we have the same thing, I guess. But it's just a good statement. 20,000, sorry, 2,146, nothing changed. Maybe it's because of one. So one should be a bit different. So, so 74,942. No, that's a tiny bit faster. A tiny bit faster. But okay. Okay, let's end the video right now. So thanks for watching this video. I'm Ritika Shamni and I am a engineer of fun. Bye.